volunteers. His name is Richard Harris. He is a geophysicist, currently retired, but we try to employ him as much as we possibly can here at the museum. We try to keep him busy. He's going to talk to us a little bit about gold in North Georgia, so thank you very much.
That was retired, not retarded. I'm sure that you know that. That was, the rock star up there was not for me, that was for Marcia. Which,
Absolutely.
I've got to appreciate, and I'll owe you the $20 later.
Thanks, you're the best.
This talk is about where you find gold in Georgia. One of the things that I've been asked quite a bit is, why is the gold here? How do you get it? And how often do you have to wait until the gold reappears? Well, gold is an element, which means that it doesn't reappear. What's there is there, and that's it. Gold was created only in one place. And Marcia, can you back up to the beginning? There's only one place that gold is created, and that is in, that's it?
Yeah, that's the very beginning.
Okay. I had a bunch of slides that showed where gold gets created in the interior of a star when it goes supernova. That's the only place that gold gets created. There is nowhere else in the universe where there is enough power to push those elements together close enough to where they bond and create heavy elements. One of the things that when our sun goes nova in about 5 million years, it's going to create things up to, say, carbon, and that's it. It's not even going to create the metals. In order to create anything higher than iron, you're going to have a supernova. Copper is heavier than iron, which means that copper is also created in supernovas. And copper chelates are what our blood corpuscles are, just copper chelates. And so without those explosions many billions of years ago, and the coming together of all of those elements and swirling clouds and things that created our universe, we couldn't exist. So we really are star stuff. To me, that's one of the most interesting things about cosmology is where things came from. But anyway, that's how the gold was created. And when the solar system was created, all of the gold that was ever going to be in the earth was there. Nothing gets, gold can't be created nor destroyed. It can only be modified and changed and added to other things. I guess you could destroy gold in another type of thermonuclear reaction, but we don't have that power. Anyway, if you can go ahead and go to the next one. When the earth was created, it had probably no heavy elements in the crust. Because if you think about it, as the earth cools, all of the heavy elements, including gold and iron and things like that, are going to migrate towards the center of the earth. Especially gold, which has a specific gravity of 19.3. That's 19.3 grams per cubic centimeter. Just to give you an indication, lead has a specific gravity of 7.6. And so gold is about 2.5 times heavier than lead. And so you ask yourself, why then is there any heavy elements in the Earth's crust? Why isn't it all at the center of the Earth? The only thing that scientists can think of is there was an event called the Late Heavy Bombardment. And that was when there were a lot of comets and meteors and things like that that hit the Earth, carrying with it elements, heavy elements, and water. All of the pox and things like that that are on the moon were created by the late heavy bombardment. And so that gives you a sense of how much material was actually hitting the Earth and the moon. And we believe that some of those impacts brought heavy elements that hit the crust, and since the crust was already formed, it couldn't migrate anywhere. It was just in the crust. And the geology of the Earth is very active. We have what we call plate tectonics, and that's where the different plates are sliding around on the surface of the Earth, being forced by the different upwellings of volcanic material and things that are creating those plates and putting putting different types of materials in the center of the plates where it spreads. Anyway, this is one of those plates, and it's coming in this way, pushing into this plate, which is coming this way. This is subducting, and it's called a subduction zone. And as it moves down, it's going to heat up a large area from friction and other things that's going to cause a melt. Now that melt then is going to migrate up, and as this occurs, this building of mountains is what happened in the Appalachians. They believed that the Appalachian Mountains at one time was probably as high or higher than the Himalayas. And so, for it to be now the size that it is, there's a lot of erosion that has gone on. Now, in this illustration, you can see these yellow areas. That's just trying to depict where some of these metals that came in from the heavy bombardment may have been. So, when this melt is going on, and when it goes up and melts other parts of the crust, that is where you can get different heavy elements in the crust that are molten, that come up and fill the cracks and the crevices of the Appalachian Mountains. And we believe that in this gold belt, that's exactly what happened. And so, at a later time, Marcia? And so at a later time, you can see how this melt is coming up full of heavy elements, and there was some volcanism along these mountain chains, not much, but enough. Most of it was, instead of becoming a volcano like this, it was just underneath the earth and slowly cooled that way, creating veins. Next slide, please. This is once it's cooled and once it's been eroded away. Now you can see on the top of the ground up there, there's a lot of gold and other heavy elements that have been eroded out of the rock. If you first go into a gold area and you're finding gold that's on top of the ground, you're doing what's called placer mining. That's where you're walking around, picking up the gold that's already been eroded out of the rock. Once the easy gold is picked up, then you have to start following those veins into the mountainside. And that's lode mining. That's a little bit too much work. Too much work for me anyway. I'd rather just sit back and talk about it. So anyway, that's how we believe the gold in this area became part of this area. It's just really, if you think about it, the luck of the draw. Other places in the United States, like Wyoming, it has areas of uranium and other heavy elements that we don't have. That's because the comets and the meteors and the things that struck there contained those elements. You may have heard, and I can't remember the name of the meteor, but I believe that it was either Jeff Bezos or somebody, one of those other billionaires, was thinking about sending a rocket to one of these meteors that seemed like it was extremely heavy. And they thought that what may have happened was that that meteor was what was left over from possibly a portion of the core of a planet that had torn apart. And they indicated that because of what the apparent heaviness of that area, of that meteor, that several quadrillion dollars worth of material could be mined from it. And for that to happen, it had to have been the core where a lot of the heavy elements, such as gold, iridium, and other things are, that are very valuable to us today. This is an indication of what the crust may look like when these things hit. Just for argument's sake, something carrying this element hit, and of course it's going to do that. There was one up there, something green there. It's messed up. It's unconsolidated. Next slide, please. Anytime you have a melt like we had earlier, you have what's called differential settling. What that means is that once it's molten, the heavy things kind of go to the bottom, the light things stay to the top. That's settling, and it's differentiating. Geologists and other scientists love to make up things, love to make up phrases and words, and that's why differential settling came around. Anyway, that which was purple was heavy and came and settled up. What was green was up there. What was yellow was even lighter still. Next slide, please.
That's the last one.
That's the last one?
Yes, sir.
Okay. The last slide supposedly was going to be a picture of someone tripping over a little gold rock. And that was what happened last. One of the little gold rocks and things like that that occurred was founded by mankind, and the gold rush was on. Does anyone have any questions for me? Yes.
I know you see me, don't pretend to ignore me.
Pardon?
I said, I know you see me, don't pretend like you're ignoring me. You talked about the Appalachians being larger than the Himalayas at one point.
Yes.
What amount of time, how do you quantify how long that takes? Like how, does it take 5 minutes, 20 years? How long does it take for something the size of the Himalayas to erode to the size of the Appalachians now?
Maybe 500 million years. That's about how long ago that this melt that filled the cracks and crevices of the Appalachians occurred. And so that happened during this mountain building event, which is called an orogeny. And so you can say that it was about that length of time that the mountains were being built up, and we can see how it is now. So 500 million years is probably a good guess.
So what was the bombardment? What age, how preceding that was the bombardment?
The bombardment, I don't really have a date for when that occurred, but you can look at the moon and see all of the craters. And you can look at the earth and see no craters. And so when that event happened, everything that hit the earth at least had time to erode away cleanly and smoothly again. So it had to be quite a long time.
Billions.
Definitely after the earth solidified,
Yeah.
but before the mountain building event. So maybe 2 to 3 billion years ago. Yes, sir.
You said before that it was, the heavy metals came into the crust as it was sort of forming and hardening. Was the creation of Earth not enough force to create those heavy metals?
No, sir.
So, okay, so inside the core there's not.
No, we
Gold.
can set off a thermonuclear bomb, and that is powerful enough to push hydrogen atoms together to create helium atoms. And that's it. That's fusion. Fission is not even as powerful. Fusion that we can do is pushing it together and making helium. The sun, when it goes supernova, is going to create things like carbon and that kind of stuff, but not even up to iron. That takes even more energy.
5 times maybe?
Possibly, yes. It's
The
gonna
sun.
take a supernova, and there are things that are even greater. One of the issues that scientists used to have was that they, in their calculations, they realized that they could make gold if there was a way of generating a lot of neutrons. There were too many neutrons in gold that they couldn't account for. In these super huge explosions, they still couldn't account for the amount of gold that exists until in 2018, they saw what they call a kilonova. It's the only one that's ever been seen in history, and we may never see it again. It's when 2 neutron stars collided and exploded. Neutron stars are solid neutrons. So, gee, that's where the neutrons come from. And when the explosion occurred, that was powerful enough to create all sorts of stuff, including huge amounts of gold. And that changed our ideas on how some of these things occur. But we can't get close. Nature can only do it in certain situations. Any other questions? Yes, sir.
So the power that you're talking about, a nova or supernova, what is it from those explosions that does it? Is it the heat, the speed of the impact? What is the power that makes it happen?
If you think of a star is trying to explode. It's like a huge hydrogen bomb. What's keeping it together is its gravity, and that's called hydrostatic equilibrium. It's just sitting there, depending upon the star, happily for several billion years or not for very long at all. When it uses up all of its fuel, it's going to collapse on itself because it's not exploding anymore. And the collapse from gravity is shoving all of this stuff together. And as it shoves stuff together, if there's anything else, if it's creating any other kind of fuel, it will then bounce back and still be a star, but it will be a smaller, brighter burning star. Once it gets to iron, however, that's where the exothermic endothermic thing happens, which means that you're now going to need more energy to shove that stuff together than you're going to get out. And so at that point, it's just going to collapse in on itself because it can't create fuel anymore. And the collapsing of that is what creates the explosion.
It's massive.
Pardon?
It's massive.
Yes, very much so. These stars, when they go supernova, oftentimes for several days, outshine an entire galaxy. That's major. Yes, sir.
How much gold was estimated to be in this area and how much still remains as opposed to what's been mined already?
We believe that about 70% of the gold remains, that we've gotten about 30% out. That's a rough estimate because we know how much gold was taken into the gold, to the mint, but we don't really have that good of a handle on the amount of gold that was circulating, being used as money, et cetera, et cetera. I would imagine that most of it eventually ended up in the mint or places like that. Because after a while, people started to trust the American currency and didn't worry about carrying around dust. So they expect that there's about 30% that's been found and 70% that's still there. The reason that we can't get to that is because Bob, his house is sitting on that, and he's not gonna let people dig up his front lawn. Same with me.
No,
Even
but
if
you-
it was there, I think that I'd rather go to the Cresson and buy their ore.
And you
And
have
so-
to go 30 or 40 feet deep and
It may be there, it's the luck of the draw finding it, but it is there. In 1995, a man walking down the Chestatee River reached down and picked up a 2-pound gold nugget. That was 23.84 troy ounces. Now, that was worth quite a bit of money, and it's huge. It was about that big. So, it's out there. You can still find it. You just have to be aware of what you say. When people ask you where you found it, you say, you can't remember.
Yeah.
That way, it's yours to keep, and you can go back at midnight if you want to. Any other questions?
Yeah, Richard, I don't know, how do we explain the purity of the gold here?
Again, that's kind of the luck of the draw. When these planetoids and things hit carrying these heavy metals, the metal was pure, and it did not hit with such a force or pressure or power to where it would create not an element, but
Alloy?
an alloy.
Yeah.
A lot of places in the United States, the gold is alloyed with copper, silver, other things, other impurities. They're valuable impurities, but not as valuable as the gold. Here in Georgia, we're lucky that the gold is pretty much pure. It's not been alloyed with anything. 98% pure, and that's about as good as you're gonna possibly get. That's why Georgia gold is so pretty. Yes, ma'am?
So you talked about the craters we've seen on the moon as evidence of the bombardment.
Uh-huh.
Does that mean potentially the moon has gold, and what about all the other planets? Do we know for a fact how much would be in each planet? Do we have any way of knowing?
One of the things that we're pretty sure of is that the amount of gold found on Earth is probably the same percentage of gold as you can find anywhere, including the moon. Well, not necessarily, but especially the heavier planets. Those planets that would have been created from a large mass of the dust and stuff. The moon, it possibly could have swept up heavy elements, but it's small and it's light, which means most of it is probably crustal material. It, however, will probably have in its crust the same percentages of heavy metals that hit the Earth. And so yes, you will find gold and uranium and other heavy metals on the surface of the moon. Yes, sir.
Say I'm impressed by your speech and I want to quit my job and become a gold prospector.
Yes.
How much money per day would I be able to make prospecting?
Well, you live and die by the assay. If you have an area and you can pick up a bunch of different rocks and you send it off to an assayer, and he comes back and says, well, now this rock here has $300 worth of gold per ton, then you can make a living off of that amount of rock, if you know where it came from on your property and if you had enough of it. If the guy says really nice rocks, you're out of luck, then hopefully your ex-boss thinks you were just joking. It really depends. It's just the luck of the draw. It's the assay. You live and die by it. Even these people on TV that are bearing sea gold and that kind of stuff, They're trying to find, you know, you can find color anywhere, but it may not be enough to cover your operation.
Pay
You
for
have
those
to-
huge machines.
You have to find enough.
Richard, I always said that because of the water cannons and everything, they were chasing the quartz veins. If you could take, because Crown Mountain was so rich as far as the number of mines around it, if you could take 50 feet of earth off of the top of Crown Mountain, you would probably find a lot of gold.
I bet you would, and I bet you would uncover a bunch of really nice little veins going even deeper.
Yeah.
One of the little factoids that we have in this museum is that in every cubic mile of seawater is 50 pounds of gold.
That's amazing.
It's there, you just gotta get it. I know where it is, by the way, so after the talk,
Hurricanes moving
yeah,
around.
come on up and we'll discuss. Are there any other questions? Ma'am, you look like you were sitting over there with just all sorts of stuff you wanna ask. Look at that, you got a question, I know you got a question. Okay. Anybody else? Well, then that concludes my talk. I am gonna be hanging around today, in case anybody wants to ask me anything, I'll be here. Thank you very much.
Thank you so much, Richard.